is the questions on the circuits. Come on, KJ. Wakey, wakey time. Your 5 minutes is over. Amanda? Right, so the first one is 2 5 ohm resistors are connected in series to a 5 volt battery. What is the current? Alright, so what you have is this. 5 volts. What did I say? In series, wasn't it? And there's 2 5 ohms, okay. 5 ohms. 5 ohms. So what's the total resistance here? 10 ohms. So you can say V equals I or. So that means I equals V over or, which will be 5 over 10. So I is 0.5. Oh, you made it. I only just started. Oh, you didn't go to SPAR. Oh, did you?
I did.
You did. 0.5 amps. That's the first one. The first question on circuits. Okay. Next. The second one is 2 and 3 ohms are connected in parallel to 2 and 4. Okay, so in this one here, you have 2 ohms and 3 ohms are connected to, what did I say? A 2 and a 4, wasn't it? So, total V equals 6 volts. And then here the total resistance. 1 over R equals 1 over 2 plus 1 over 3. So 1 over R equals 5 over 6, isn't it? So R equals 6 over 5. What do I ask for? Is it the I again? Yeah. So I equals V over R, which will equal 6 over 6 over 5, which will equal 5 amps. So that's the I here. Number 3. Okay. Can I do number 3 now? So in number 3, this one was a bit interesting. Hey, come on. The electrical company, door. Thank you. The electrical company is laying down 2 copper wires.
200
How big?
200
200 kilometers. 200 kilometers. And the diameter is 4 centimeters and 4 centimeters.
E is equal to 1.72.
And the rho is equal to
1.72 into 10 minus 0.8. Oh, minus 6.
yeah, like this.
Yeah.
Okay. Right, so resistance in one of the wires is equal to rho L over A, which will be 1.72 times 10 to the minus 8 times 2 times 10 to the 5 all over pi 0.02 squared. KJ, what do you get?
It's 2.74.
2.74.
Oh.
Yeah? Now that's not the final answer though. Yeah, the other one is the same. But what's happening here is the electrical company is using the 2 of these. So what type of problem is this? Series or parallel? Parallel. So the answer is not this plus the other one. It's like this. The total is 1 over 2.74 plus 1 over 2.74. Not 2.74 plus 2.74. So this is 2 over 2.74. So therefore the total resistance is 1.37 ohms. Okay? Yep. Next one. When two resistors are connected in series, their total resistance is 3, and when they're connected in parallel, it's 1.2. So what that means is, when they're connected in series, the total is 3, and when they're connected in parallel, the total is 1.2. I'm not going to go through this because it's just a maths problem. It's two equations with two unknowns. Although I will ask you, what's the best method to use here? Substitution, elimination, matrix, graph? Substitution. What you should do is take R1 or R2 and put it in here. So you would get like something like this. 1 over R1 plus 1 over 3 minus R1 equals 1.2. Huh? Solve it. You're going to make your maths teacher upset. Right, we multiply everything by R1. So you get 1 plus R1 over 3 minus R1 equals 1.2 R1. Then we should multiply everything by 3 minus R1. So we get 3 minus R1 plus R1 equals 1.2 R1 times 3 minus R1. So they'll cancel, and I'll get 3 equals 1.2 R1 times 3 minus 1.2 R1 squared. So I'll get 1.2 R1 squared minus 3.6 R1 plus 3 equals 0. So you'll get two answers for R1. R1 equals 1 or 2. And when you substitute this back in, you get two answers for R2. R2 equals 2 or 1. So the answer is 1 and 2 or 2 and 1. Okay, next one. Last one, is it? Yeah. I have a diagram here. Okay.
You can get E, you can find E minus.
Hold on, I haven't drawn it yet. I haven't drawn it yet, so I don't even know what the question is. What's the first one? It's an R1 like this. Okay. R1. What one's up the top? R2, is it? Is it?
3,
Or I can't see.
2. R2 is.
R2 is on the top, is it? Yeah. R2, and then at the bottom,
R3.
R3, and then okay. So I tell you how big these resistors are, don't I?
6.
Oh wait, hang on. So how much the first resistor?
2 ohms.
2 ohms, and the second one?
3 ohms.
3 ohms.
4 ohms.
4 ohms, and then the battery?
6 V.
6V.
Is that E
No,
equal to
12V. 12, not 6. Can you see why? There's 2 batteries of E. Look up, there are 2 batteries of E. E is 6, there are 2 batteries of E, 2 cells of E. Can you see? Right, okay, so my question is basically what is the current here and the voltages?
First you get total I.
First, yes, correct. First get total OR. So 1 over OR equals 1 over 3 plus 1 over 4. So this means 1 over OR will be, let me see, there's a 7 over 12. So OR equals 12 over 7. That's for these two. Then if I add it together with 2, I get OR total is 14 and 12, 26 over 7 ohms. So that's the total resistance. What's the total voltage? 12. So if I want the current here,
Total current, right?
total current, yeah, I can use I equals V over OR. So that would be 26 over, no, that would be 12 over 26 over 7, so 84 over 26 amps. Which we can simplify as 42 over 13 amps. That's how much the total current is. Okay. So now let's get the voltage here. Look. Here, let's get the voltage here. So you can use the V equals I OR formula. What's the I? 42 over 13. And what's the OR? 2. So the answer for the first one will be 84 over 13 volts. Now who can tell me what the voltage
6.
is here? Who knows what the voltage is there?
Well,
Oh, you're telling me this answer is 6?
Yeah, 6.46.
Nice. Oh wait, sorry. What is it?
6.46.
6.46. Okay. What's the voltage here?
12 minus 6.4.
Very good, Karar. 12 minus 6.64. So what is that, please?
5.53.
5.54 about. So the voltage here and the voltage here are both 5.54. So you can now work out the I. Up the top, the I up the top is V over OR, which will be 5.54 over 3, which is what, please?
1.846.
Okay. And then down the bottom, I just did the top down the bottom. I equals V over OR again, which would be 5.54 over 4, which is what, KJ? 39 amps. Now, Fahad, can you give me this number here as a decimal, please? The number we got at the start. Oh, sorry, or this number here, 42 over 13. KJ, can you add this number and this number?
3.23.
3.23 amps. Perfect. So, if you look at what's happened here, look up. At the start, my current was 3.23. Hang on. At the start, my current was 3.23. Here, true. Later, I got the current at the top and at the bottom. And it's not a surprise that when I add those two answers together, I get the total current. Because look at what's happening. You see up the top, the two wires are coming along like this, and then they connect together. So the current here plus the current here, it should equal the current at the end. So this number plus this number, it does equal this number. So this is how I can know I got this question right. There's no mistakes in it. Yeah?
So if I add them, I got the currents of R1 and R2.
Yeah, the current through, the current through R2 and R3 is the same as the current through R1.
The same.
The same. Well, if you add them together, I mean.
Yeah.
R2 current plus R3's current should equal R1's current. Because if you remember, when you have current and they come together, they add.
Yeah.
Voltage is the same, but currents add together for parallel. Yeah.
So now we should get the voltage, right?
Well,
B.
we have the voltages. 5.54 is in each of the R2 and R3.
Yes, because they are like
They're
parallel.
the parallel, they're the same. And we have the voltage in R1. What did we say it was? It was 6.46.
Yes.
So we have all the information here. Was that the last one? I asked you for current and voltages, didn't I, for all the resistors? Yeah.